Okay, and I've driven those through those two nylon screws at the top. Okay, and the whole thing now is assembled, and you can see it's a fairly rigid arrangement, which is good just in case there's any vibration that this whole weather station experiences if it's a windy day out and so on. Okay, and just so you know, none of these boards were meant to, they were not designed such that the holes are placed perfectly so that the whole thing can be assembled in this fashion. These are four separate boards that Adafruit makes, and they have the holes there for general flexibility, but this is not to any overall specification, right? I'm combining these as best we can do for our purposes, but it's not all manufactured with these holes perfectly in place so they all can be assembled this way. So my point is, if you find yourself having to bend these nylon screws or position them around to get them to all connect together, that's fine. You can see here that nothing here is perfectly parallel. I've had to bend this one out just a little bit in order to make these two holes line up. Okay, because it's nylon, it has a little bit of flexibility to it. And when you're screwing these all together, I recommend not clamping down the first screw all the way until you've put down the second one. Okay, so you're going to want a little bit of flexibility as you're assembling the whole configuration. Okay, but that's pretty much all of the electronics. The last thing to do is to attach an on-off switch. This whole thing would do that with this LED button. Okay, so the button looks like this. It comes in different colors. If you want to order a different color than the green one here, that's fine. But basically, this acts as a control for the whole system. Okay, and primarily you'll want this when you're first assembling it, when you're finalizing the whole thing, and before you're ready to deploy it out on your roof or outside or wherever it is you're going to position your weather station. Okay, and so when you press down the button and the whole thing is connected as it should be, then power will flow through the system. The button will glow its color. This one will glow green, and that's an indicator that the station has power and that it's on, and at least power is flowing through this particular part of the system. So what we're going to do in order to make this work, we're going to position this button between the buck boost board, okay, the output of the buck boost, and the rest of our board, okay, namely the BME 280 and the Huzzah. Okay, so this button, when it's on, okay, when it's pressed down like that, it's going to allow power to flow from the buck boost to the Huzzah. Okay, if power isn't flowing and it's in its off configuration, the LED will turn off and the Huzzah will not receive any power, and subsequently neither will the BME 280. Okay, and since the Huzzah is one of the biggest consumers of power in this whole system, the idea is that I recommend that you start with your battery fully charged. You can do that independent of the solar panel. You can charge it up in your office or somewhere that you have power, okay, and then connect it to your system, as we'll show in a little bit. Okay, but have the whole thing once you're done testing it and you're ready to deploy. Put the whole thing in a low energy state by turning off the flow of power from the solar panel and the battery. Okay, and do that by just turning off this button. Okay, when you do that, nothing will flow past the buck boost. Okay, and then once it's in place, go ahead and open up your enclosure, your electronics enclosure, and turn it on, and then the whole system should then be operational. Okay, so we have to connect a few wires to make this whole thing work. If you look at the bottom of this LED button of this control, it has 4 different terminals that come up. Okay, and for that, I suggest that you prepare 3 red wires and 2 black wires. Okay, and you're going to want to make them long enough so that you have flexibility to position this and make all of our connections. Okay, we're going to have to solder the wires on this end into those terminals, and I'll show you that configuration in a moment. And then on the other end, they will then be inserted into the 2 terminals on the board that remain. Okay, so this terminal over here, that goes into this voltage divider in the corner. Okay, and that regulates the voltage because the button actually has different power requirements from everything else. Okay, and then ultimately the power is going to go into this terminal over here, and that terminal, which is the topmost terminal, okay, if you remember when you put this all in originally, that's what ultimately passes the power to the Huzzah. Okay, so we have, if you look closely again at the top rail is ground, and the secondmost rail is positive. Okay, and so that'll be the power from the button. Okay, but again, because the button itself needs a certain amount of power, we have to downregulate what comes out. Okay, when we do that via this voltage divider over here. Okay, and then two of these other wires are going to go to the buck boost output. Okay, and that'll be this terminal over here that's still not connected to anything. Okay, so ultimately we'll have to take off, once we connect that, we'll have to take off our power management board so we can access those screw clamps, okay, on the buck boost. Okay, but that's easy enough to do because that's just removal of really one of these nylon screws, and they can pivot the whole thing, clamp down, insert and clamp down those wires, and then swivel the power management board back into place, and then put back in the other nylon screw. So I'll show you what it looks like. Okay, but that's where we're going. And next I'll talk about how exactly we want to connect this rat's nest of wires. Okay, but you want to prepare 5 of these wires here, 2 black and 3 red, and make them, if you stretch this out, right, you want to make them a good 4 inches long or 5 inches long. Okay, we can always trim, and we can always not worry about the overall length if it's too long, but if it's too short, that is going to be a problem. Okay. Okay, so the final soldering job involves preparing the LED button as a control on-off switch for our station. Okay. So if you look at the back of it, there are 4 terminals, and if you look closely, which is difficult to do in the sliding here, but if you look closely, there is a positive plus and a negative symbol on either side. Okay, so we have this arrangement of the 4 terminals, and 2 are sort of closer towards the top, other 2 are closer to the middle. If you think about dividing this into 2 different halves on the back here. Okay, so you'll find the plus on the left side and the negative on the right side. Okay, but again, I can't really show you that very well here in the lighting. Perhaps on the right hand side you can see that negative sign. So what we're going to do here is we're going to connect, we're going to solder the 2 black ground wires to the bottom rightmost terminal. Okay, and when you buy this, I can't show it to you here because I've already soldered this particular unit, but there's a through hole in each of these terminals through which you can pass the exposed end of the wire. Okay, so feed that through, and I've done that for here for both of those. You can see them sticking through, and then you're going to solder that to connect it. Okay, and then you can just draw those 2 wires out to the right, okay, and get them out of the way as you prepare the other 3 terminals. Okay, and those other 3 terminals all get 1 red wire each. Okay, so that's fairly straightforward. It doesn't really matter where they all go at this point. It's just that you need to have those 2 black ones connected to the bottommost right on that negative side. Okay, and the other reds each go to 1 terminal each. Okay, so the issue now is where to connect those other wires. Okay, where to connect all 5 of those wires. What I've done to help me keep myself organized here is I've given 3 marks, 2 marks, and 1 mark to each different red wire. Okay, that helps me keep track of where they all go. Okay, so the wire that has the 3 marks over here, okay, it's on the top left of this configuration, so that's the top side of the positive half of this of the back of this LED button. Okay, so the one with the 3 hash marks that I've labeled on it, that one is going to go to the output of the buck boost. Okay, so again, looking at the board, okay, here we have it in our usual configuration with the Huzzah on the left, the MB280, buck boost, power management. Okay, so remember this part here coming out, that's going to feed into the load terminal. Okay, we'll connect that in just a little bit, not just yet though. Okay, and if we turn it around and look at the back side of the board, we see those 2 other terminals, and that's the output side of the buck boost. So what we're going to do is we're going to connect the red wire that has the 3 hash marks on the top left into the positive side of that terminal. Okay, I'll connect that and show you that once we have everything connected here. Okay, going around in order for the other components, on the bottom left, okay, that's the one with the 2 hash marks. Okay, that is going to go to our voltage divider. Okay, so turning the board around so we can see where that goes. The voltage divider is this bottom rightmost corner of our breadboard, and that's where we have the 2.2 kilo ohm resistor going to positive over here, and the 10 kilo ohm resistor over there, and that's this terminal that's sort of off by itself on the bottom side of our breadboard. Okay, so once again, the wire with the 2 hash marks on the bottom left, that's going to feed into the leftmost terminal that we have down here on the right, bottom right of the breadboard. Okay, again, I'll show you that. And actually, the rightmost terminal over here is not going to receive an input, so we don't have to worry about that one at all. Okay, and then continuing on with the other wires, the other red wire. This is now the one with the single hash mark. Okay, that wire is going to connect to the terminal that's on the top rail. Okay, so that's going to connect to the positive, the terminal that aligns with the positive row. Okay, this is the secondmost row from the top. Okay, and that's going to connect roughly our 5-volt voltage out of the buck boost. Okay, it's going to energize the top part of the circuit. All right, so that's what we're going to do with that, and then we have the two black wires. Okay, so we've got 2 of them. It doesn't matter which one goes to which. Okay, they both have the same connection, but that basically passes the ground on through. So one of those black cables needs to go into the negative terminal of the buck boost. Okay, over there, and clamp that down. Okay, and then the other black wire, it doesn't really matter which one it goes to, because the ground is shared between the bottom half of the board and the top half of the board. Okay, but it might just be easier to connect it into the top terminal. Okay, so that's going to be the terminal that's connected, that feeds into that top rail that goes across the top row. Okay, this noted with a negative sign. Okay, and if you follow our circuit diagram through for the breadboard overall, we'll see that we have a shared common ground between the top and the bottom. Okay. So the top is going to be 5 volts, the bottom is going to be 3 volts. We get 3 volts off of the Huzzah, and we regulate the 5 volts down to 3 volts for the Huzzah as well. Okay, so that's where each of those wires are going. So go ahead and solder each of those connections. The manual says 6 inches for the wire. Anywhere between 4 and 6 inches should be fine for this arrangement. Once they're in, we can then, once they're soldered, as they are here now, I'll then connect them to each of the terminal locations so you can see where they all go. We can try to trace it through as best we can. Okay, so I finished connecting all of those cables into the terminals. You can see that we have this one is the one with the with the 2 hash marks. That one is going into the leftmost terminal of our voltage divider. Okay, that is how we get 2.2 volts. We have 3 volts that then our voltage divider turns that into 2.2 volts and sends it back up to the LED, and that's what actually gives us the light. That's what illuminates the light. Okay, so the button will always pass along the voltage regardless, but in order for the light to work, it needs 2.2 volts. So we actually send that back through and send it back up and around again through that voltage divider. So the one with the 2 hash marks goes in there, okay, and we screw down that terminal. You can see nothing is connected into the rightmost terminal port over there, so don't worry about that. I have taken out the screw of the leftmost nylon standoff so I can swivel my power management board off to the right. Okay, so you can see it's just one point of connection there. And I do that so that I can access the 2 screws for the terminal that comes off the buck boost. Okay, so into those I've inserted 1 black ground wire and then the red wire here. Okay, and that's the one that has the 3 hash marks on it. Okay, maybe difficult to see at this point, but there it is. Okay, and I've screwed those down. And now that that's done, I can then swivel this power management board back in. I can screw it back in with a nylon screw. And then the final 2 wires, black, okay, and then the one with the single hash mark, those go into the terminal that's on the top row here. If we look at it from our usual configuration, that's what passes on the 5 volts out from the buck boost. Okay, so I have positive on the bottom in red, ground on the top in black, okay, and then I've screwed those down. And it's a good idea to check all those clamp connections because sometimes they can be a little bit tenuous, and a good way to do that is just to give a small tug on each of these cables after you've clamped it down and screwed it down, just to make sure that it is a good connection there. Okay, and with that done, we can then swivel the power management board back into place, and we can then reconnect, fasten it down with our nylon screw.